prime factorization. What is prime factorization? Hey, my name is Jason Jacobs. Welcome to Math with Jason Jacobs, and I'm going to teach you all about prime factorization. So did you guys know that every single number in the world is made up of the product of prime numbers? So you can reduce every number down to just the product of prime numbers. And you can do a number of different things like that, like find the least common multiple or greatest common factor, which I might show you as an added bonus to this. But let's get started, and I'll teach you about prime factorizations and two different ways to write it. So here we go. What's the prime factorization of 24? Well, let's see. 24 factors out into what times what? What are two factors? Maybe you said 6 and 4, or 4 and 6 if I use the commutative property. 4 and 6. Now, 4 is composite. It's composite because it has 3 or more factors. We got to get it all the way down to prime. Now, a prime number is a number that can only be factor down. It's only made up of 1 in itself, is what I'm trying to say. Like 2 is the only even prime number because 2 factors are 1 and 2. It only has 2 factors. So a prime number will only have 2 factors, 1 in itself. So let's see, 4 can factor out into 2 and 2. Now, 2 is prime, so I'm going to circle it. And 2, so once it's prime, I like to circle it so I know what to use later. 6 factors out into what times what is 6? That's right, 2 times 3. So 2, it's made up of a 2 and a 3. Now, once you can't bring it down even more, because if I did 3 and 1, well, that would just end up doing that forever, right? So they're already prime, that's why I circle it. And now the prime factorization of 24 is 2 times 2 times 2 times 3, okay? 2 times 2 times 2 times 3 is the prime factorization of 24, or you could use exponents, 1, 2, 3 2s. So you could write it as 2 to the 3rd power times 3. So these two answers are acceptable. Hey, let's do, what's the prime factorization of 56? Well, 56 can factor out into what times what? Well, you might have said 8 and 7. Now 7's prime, so I'm gonna circle it, okay? So now, 8 factors out into 2 and 4. Well, 2's prime, so I'm going to circle that. And then 4 factors out into 2 and 2. All right, so the prime factorization of 56 is 2 times 2 times 2 times 7. Now, because of the commutative property, you can write them in any order you'd like. I like to go least to greatest with my factors. So 2 times 2 times 2 times 7 is 56, and that's the prime factorization of 56. And you could also write it like this, guys. There are 3 2s, so you could write 2 to the 3rd power using an exponent times 7. So that's also acceptable. Now, I wish I would have said this earlier, but you might be thinking, wait, when you were doing 24, you did 4 and 6, but what if you did like 12 and 2? Would it still work? Well, let's see. Let's see, what do you guys think? Will it still work? Well, let's say you did 2 times 12. Well, 2's prime, that's why I circle it. I'm just in the habit. As soon as I see it, I circle it. You know, like those whack-a-mole games, when it comes up, you hit it. It's like when I see a prime number, I circle it right away. So, like 12 factors out into 3, prime. Instead of hitting it, I go prime. And 4 factors out into prime, 2 and 2. So, let's see if it worked. 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. See, any way you slice it, it's still bread. So whether you do use 6 and 4 or 2 and 12 or 3 and 8, it'll still work. All right, so now what if you wanted to find the greatest common factor and least common multiple of 24 and 56? Well, let's do it now. I'm going to make a Venn diagram. And 24 was 2 times 2 times 2 times 3. And 56 was 2 times 2 times 2 times 7. Now, we want to find which ones they have in common. Which prime factors do they have in common? Well, there's a 2 here and there's a 2 here. So that's 1, 2 that's in common. Oh, look, there's another 2. See, these 2's are in common, so I put it there. And then these 2's are in common. So they have 3 2's in common. Now this 3 is not in common because there's not a 3 here. And this factor of a 7 is not in common. So now, to find the greatest common factor, instead of listing out all the factors of 24 and all the factors of 56 and possibly missing one, you just take the product of the common primes. So what's the product of the common primes? Well, there were 3 2's in common. 2 times 2 times 2 is 8. So the greatest common factor is 8. Now, the least common multiple. Well, instead of listing out all the multiples of 24 and trying to find a match of all the multiples of 56, here's what you do. In your Venn diagram, you multiply 3 times the center one, 2 times 2 times 2, times 7. So 3 times, remember, the 2 times 2 times 2 is 8. 3 times 8 is 24. And now we have 24 multiplied by 7. And you get 168. So the least common multiple here is 168. And that's how you can use prime factorization to find the least common multiple and the greatest common factor. And this was over prime factorization. And my name is Jason Jacobs, and this was Math with Jason Jacobs. Like and subscribe if you want to. I'll see you next lesson. Bye.